June 2016, paper 1. This is question number 3. Different types of waves are used in hospitals. Which of these properties is the same for all electromagnetic waves? Well, is it the amplitude? No, because the amplitude is just about how much energy it has. Frequency? That can't be right because the electromagnetic waves go along this. They're on a spectrum, which is based on frequency or wavelength. So it can't be this one either, so it leaves the only one to be. All electromagnetic waves travel at the speed of light, which is 3 times 10 to the 8 meters per second. Draw a line linking each type of electromagnetic wave to its use. Remember, when you're doing the electromagnetic spectrum, the first couple you should remember because they go together. So radio waves and microwaves, they go together because they deal with information. So that's communication. Radio and microwaves are used for communication. But then microwaves and infrared waves go together because they both heat food. So we've got microwaves here, and that's used for heating food. X-rays, pretty straightforward, imaging the bone. Gamma rays, medical traces. Electromagnetic waves are transverse. Describe how the vibrations of a transverse wave relate to the direction in which the wave travels. Well, we could do this. So here's our wave, and I could put that it's going this way. Now, if I put a molecule here, or something that's going through, in order to make that wave, that particle has to go up and down, whilst the wave is going left to right. So I'm going to say vibration, I think I spell it right, vibration is perpendicular, that's the most important word, perpendicular to direction of wave travel. What a lot of people do is they miss out that wave travel part, so they just put vibration is perpendicular to direction of travel. So it really needs to be the wave travel. You need that idea that the wave is going this way, but the molecule is going up and down. The vibration is up and down. Another type of wave used in hospitals is ultrasound. Ultrasound waves are used to make images of internal organs. The scanner emits an ultrasound wave into the patient and records any reflections. The frequency of ultrasound waves is outside the range of human hearing. Which of these could be the frequency of an ultrasound wave? Well, that's within our hearing. We should remember that our hearing is that. That's the range of hearing for a human. So it can't be that one, and it can't be that one. So if it's above the range of hearing, it has to be that one. Okay, the scanner records the time from when a wave is emitted to when it's reflected. The reflection is received. A technician calculates the depth of the reflection using the equation depth equals half times speed of ultrasound in patient, time recorded by the scanner. Explain why the technician uses the half in the equation. Explain. So we need a reason in there. So we say wave travels there and back. So if we want the depth, we need half this distance. You could also say depth is half total distance, or time to target what they want to measure is half the total time traveled. As long as you're getting it in that you need half the distance. So I've got wave travels there and back, so I'm showing them I know it's going there and back because of that reflection. And then we want half that depth. If we want the depth, we need half this distance. So looking for that word half. An ultrasound wave travels faster in the patient than it does in air. Explain how a change in speed affects the wavelength of the ultrasound wave. So you need wavelength is longer in patient because it travels faster in the patient than it does in air. You should know that frequency does not change. Frequency never changes. So wavelength must be longer because we're going to use this equation. Equals f times lambda. If this doesn't change, and if this goes up, this must also go up. This is the part that was getting you the marks to show that the frequency does not change. And that was question number 4.